Hello everyone. This is the video lecture for College Algebra Math 1414 Section 5.1 Angles. So we're going to be doing trigonometry. Woo. When I mean trigonometry, I mean sine, cosine, and tangent. And that is chapter 5 right there. Before we even get to that, we've got a lot of other things to get started with. We're going to just start by talking about degrees. I want to try to make it look a little bit better. Degrees. And then also radians. Everyone's familiar with degrees. We got 0 to 360. We all think in degrees. This is not an issue at all. 0 degrees is over here. We go counterclockwise until we get back to 360 degrees. Some other key ones are 90, 180, and 270. I'm not worried about you knowing degrees. Why did I say counterclockwise? It should have 2 C's. I'm not too worried about degrees. I'm worried about myself, apparently, but well, whatever. Well, it's lighthearted. So here's quadrant 1 in particular. We got 30 degrees, 45 degrees, 60 degrees, and 90 degrees. So that's just quadrant 1 right here, basically. We're going to be using those in particular as we keep going counterclockwise. As we go this way, counterclockwise. Okay, there we go. We did it right this time. Okay, so what about radians? Well, it's the same thing as degrees, except it's a different numbering system. We start with 0, and we go all the way to 2 pi. 2 pi is a full revolution. Keynotes along the way are pi over 2, pi, and 3 pi over 2. Here in quadrant 1 in particular, I'll just go ahead and draw it right on top, we have pi over 6, we have pi over 4, and we have pi over 3. Okay. This is a copy-paste of this stuff. So basically you can just say, hey, I got pi over 4 radians. What kind of degrees is that? And you can just look over here and say, oh, it's 45. So they're a copy-paste of one another. Of course, I need to give you some kind of a formula. So here's a formula on how to convert back and forth. Let's say that I have I want degrees and I want degrees and I have radians. So degrees is equal to radians times 180 degrees over pi. The other one is that I want radians and I have degrees. I guess I could put degrees, plural. I'm going to multiply it by pi over 180. I remember how to do this because of the degree symbols and the pi's and stuff like that. So here's an example. Definitely got to talk about an example here. Let's just say that I have 210 degrees. And they say blank radians. Okay, well, I know I need to multiply by a pi and a 180. So is it going to be pi divided by 180? Or is it going to be 180 over pi? And this is the confusion part. Well, this is how I see it. Degree symbols here cancel, and we're left with a pi, which is something that radians wants. I believe it's 5 pi over 3 whenever you start reducing it down. But notice here, these degree symbols do not cancel. They combine together to make degrees squared. And that is completely not anything that we are going to use. That's not useful. So this is not the correct formula. So what I look for is degree symbols canceling. Let's do one more example. Let's say that I have, and I'm just going to make something up here in radian mode, 3 pi over 4. And they say find blank degrees. So again, I can multiply this by 180 over pi, or I can multiply this by pi over 180. Now I want to know which one. Notice here, the degree symbol is in the numerator. That basically means the whole thing's going to be a degrees. These pi's cancel out in particular, so that's really nice. I think it's 135. But here, I don't have the pi canceling, so I have, like, you see these guys? I got pi squared, which is kind of weird. Not the worst thing, but the worst thing is divided by degrees. So it's like inverse degrees. None of that makes sense. So I remember my formulas by, you know, canceling and that kind of stuff. Okay? Well, there you go. I have one last formula for you, and then we're going to do some problems. This is arc length. I cannot remember if they do the other formulas in this section or not, but definitely the arc length one. S equals R theta. Sorry about that. So this is my arc length. That's my radius. And this is theta. Theta. It's a Greek letter. Makes the th sound. Seriously, that's the sound of it. So theta. And it basically means angle. It means angle. Now, one thing in particular, theta doesn't always mean angle in radians, but we need this form here, this one in particular, in radians. Not because it's a theta or something. That's not the point. Theta is just angle. That's whatever. You can use degrees or radians. But for this formula to work, you're going to need to use radian mode, I guess you can say. Like if you're putting in 20 degrees, it's going to all be messed up. Arc length is basically some kind of length here. Oh man, that's probably the worst thing I've ever drawn. Let's try that again. So I got a circle, let's say, but not full circle, but some part of it. Some part of a circle. And this internal angle here is my theta. And my r is the radius of whatever that circle would be if I kept going, you know. What's the radius? My s is then this outside arc length here. That's s. Okay. Surely you know the formula for the circumference of a circle, right? Do you remember that one? I asked my pre-cal folks the other day. It's not pi r squared, it's 2 pi r. This comes from, it's a derivative of this right here. Notice that we have our angle is 2 pi, meaning a full circle, and then we have our radius. So this right here is s equals r theta all over again. Okay, and that's kind of how I remember how do I remember this formula? I just look at this 2 pi r business that I remember, and I kind of say, oh, well, if that's a full circle, then I could just change this angle here to whatever I want. Let's just say pi over 3. You could just change it to pi over 3, and ta-da, it works. Okay, but that's enough of the formulas. We're going to actually have to do math at some point, so 517, here we go. It says I got a radius of 40 inches, and then it says I have an arc length of 20 inches. And they're saying find theta. So I have s equals r theta. I have 20 is equal to 40 times theta. Divide by the 40. 20 over 40 makes a half. So what is this half? That's actually an angle. It's an angle, right? Theta's an angle. But it's in radians. So it's half radians. 0.5 radians. I don't know exactly where 0.5 radians is. It's not like it's as easy as degrees. Just real quick here. So just decimal mode for a little bit. This is 0 radians. This is 1.57 radians. This is your pi, 3.14 radians, and so on and so forth. So where is 0.5 on this circle? It's about right here, I guess. 0.5 radians. but that is not like 30 degrees. It's not simply anything, honestly. It's just a number. So type it in and you're done. Okay. We'll get more meaningful results here pretty soon. It says my radius is equal to 1 meter. My arc length is equal to 800 centimeters. Which, by the way, if we're doing meters here and stuff like that, convert this over. This is 8 meters, by the way, because centi means 100, so you divide by 100 to make the 8. Okay. And, of course, they want what's the angle. So then I got my S equals R theta. I have 8 is equal to 1 times theta. Well, 1 times anything is just gone. So 8 radians. Yeah. It's kind of a weird thing. I mean, that's what I got for my answer there. If you want to visualize this, I don't know how I would ever want to visualize this thing. So a full circle is actually 6.28 radians. And then this is an additional 1.5. So we'd get a little bit further over here, is what my guess is. Somewhere over there, I'm thinking. But I went all the way around, and then I went some more. So it's kind of like I just like a shoestring on a stick or something. I just keep wrapping it around or something. I don't know. Moving on. 8 is your answer. Put in an 8. Move on. 5, 1, 13. So it says now convert 5 degrees into radians. This is actually very simple, of course. 5 degrees times, what do? I'm going to do pi over 180. The reason why is because the degree symbols are going to cancel. So basically I got 5 over 180, and then I put a pi in the front. I'm going to use my calculator right quick on this. 5 divided by 180 is 1 over 36, and then a pi. And that is your exact answer for sure. My math lab has the little blue text down here, if you recall. They always do. And they say here in this particular one, it says exact answer using pi. Okay, so they say that you need to have a pi in your answer. There you go. Okay, 5115. So I got 171 degrees is equal to blank radians. So of course I need to multiply. 171 degrees times, what do? I'm going to do a pi over 180 because again my degree symbols cancel. So I do not know what 171 over 180 yields. I'm going to use a calculator for that. 171 divided by 180, and I got 19 over 20 pi. By the way, I'm using just a small little Casio here, scientific calculator stuff. Any basic scientific calculator will convert these fractions. The TI-30s will definitely do it as well. It's just kind of weird to find. I would say go and look it up where and how to make your scientific calculator change into whatever kind of fraction. Desmos scientific calculator, of course, will also do it. So that's definitely always available. You do not have to purchase a calculator. Okay, I got pi over 3 radians is equal to blank degrees. It feels like I'm going backwards here, but I'm trying to remember formulas here. Am I going to do a pi over 180 here? Well, no, because the pi's are not canceling, you see. And that's not really the most, I guess, that's not the key to knowing if it's actually going to work or not. But one point, though, is that this degree symbol here is in the bottom, and that's no good. What I'm trying to get at is sometimes the pi's are going to cancel. I'd say almost most of the time. But that shouldn't be the one factor that makes this correct or not correct, okay? It's that degree symbol, and notice it's in the bottom. That's no good. So we want the other one. This is how I reason through it in my mind. Like, hey, which one am I supposed to multiply by? I keep doing this in my brain until I figure out it works. Well, here the pi's cancel. That's good. That's not necessary for this one, but it is good. And look, we got a degree symbol on the top. That part is necessary. So I've got my 180 degrees divided by 3 would make my 60 degrees. And that's your answer. Cool. Okay. I put little notes in my notes about that sort of stuff. That's why I'm trying to remind you about that. 19 pi over 12, and that's a radians. Convert this into degrees. Okay. So I'm going to multiply it, of course. Always will. I'm going to do 180 over pi so that I can cancel my pi's out. Again, I have a degree symbol in the top. And so it's 19 over 12 times 180, which is definitely calculator. I don't know that stuff. 19 divided by 12 times 180 is 285 degrees. There it is. Next question. 5141. I got 5, trying to make it look better, 5 pi over 3 radians. And they want to graph this thing. What do they mean by graphing this thing? What is that? So I'm thinking it's a multiple choice. I have a picture. I just boxed it in, and then there's this quadrant thing after it. I always start here at 0, and I want 5 pi over 3. So here's what I do. First off, you could go back to like my circles that I drew at the very, very beginning and start to reason your way to 5 pi over 3. But yeah, I don't know. You know what? I think I messed up one earlier. Oh well. I think I said it was 5 pi over 3 when it was a 4 pi over 3. I can't remember. I'm gonna keep moving. I'm not gonna go back. I mean, hey, it's impromptu. You know, this sort of thing happens. Moving on. So how do I really know how to graph this thing? I'm gonna convert it. I know degrees. I don't know radians very well, and so I'm going to convert it. I think it's 180 over pi. Yep, cancel the pi's out. We're good. 5 times 180 divided by 3 gives me a 300. So 300 degrees. Where is that? Well, this is 0 degrees, 90 degrees, 180 degrees, 270 degrees, and then a little bit more. So this is what my graph would be. Lastly, they're going to say, hey, what quadrant are we in? We're in quadrant 4 down here. Quadrant 4. 5145. I got negative 7 pi over 4 radians, and they want to graph that. Notice that it's negative. Means that we're going to go backwards. We're going to go clockwise this time. Starting here, we're going to go this way this time. Negative 7 pi over 4. I don't know where that's going to be. How do I do it? So I'm going to convert this by multiplying. Let's say 180 over pi. Cancel, cancel. So I got 7 times 180 divided by 4 makes a negative 315. So again, this is negative 90, negative 180, negative 270. This is negative 360, so we're not that far. If you keep going, it'll be over here. It's basically like all this right here is 45 degrees, by the way. Okay. What quadrant are we in? I'm in quadrant 1. Okay. Turn the page. 5157. So I have a 525 degrees, and they want some coterminal angle. And they say that this must be less than 360 degrees. Okay, so what's a coterminal angle? What do they mean by that? Let's just say I have some kind of angle right here. And then I start here. It's actually 45 if you want to know. And I go all the way around, all the way around, all the way around. And then I come right back to where I am now again. Notice that I'm literally on top of the last one. That's coterminal. They're on top of one another. Here, let me go another full circle. So I'm starting there again. I'm going another all the way around. And there's another one. There's three arrows right on top of one another. That's what coterminal means. They're right on top of one another. But you can see the difference between each one of them is a full circle. So it's kind of like I'm winding it up, you know, and every time I'm at that particular point is that point, I guess you can say. I don't know, just if you want to kind of look at like a slinky or something. I guess the radius would be right here in the center. Yeah, trying to make it look cool. We do this kind of stuff all the time in Calculus 3. You're going to take my Calculus 3 class, correct? Okay, so it must be less than 360. What do they mean by that? Well, I'm going to basically backtrack. So let's say that we have this right here. And I want to backtrack out of that green back to the magenta by going backwards 360. So I'm going to minus 360 from it. And then how do I get back to the black? I'm going to do it again, minus 360 again. I'm unwinding it, essentially. So for this particular angle, though, I'm going to subtract 360, and I'm just going to see where we lie. Where are we? So let me go to the calculator. 525 minus 360. Where are we sitting right now? And I got a 165. Is that less than 360? Yes. So you're done. That was it. Ta-da. Very simple. All I'm doing is subtracting 360. Wow, is that all I do? Yep. 159. But I had to explain it, of course. Negative 335. And they want something that's coterminal. Same idea. Now, they're wanting a positive, I guess a positive angle less than 360. So let's try to figure that out. Whoops. I guess that happens to zoom back out. Okay. So if it's already negative and I want to make it positive, I'm just going to add 360 to it and see what happens. So negative 335 plus the 360 makes a positive 25 degrees. Is this answer, is that positive? Yeah. Is it less than 360? Yeah. Basically, they're saying, is it somewhere here in the first revolution? The first revolution. The first circle. And yes. Yes, it is. So we're done. We don't have to keep doing that anymore. 165. Same thing. 59 pi over 6. And they want something that's coterminal. Again, from 0 to 360. Same thing. Problem is that we have radians. My answer is also going to be in radians. And so I'm wondering, well, what do I do? The last time what I did is I added 360 or subtracted 360 or something like that, 360. Well, here we're going to add or subtract 2 pi instead because we're in radian mode. Now, how do we subtract 2 pi from this thing? Let's just line it up here. Let's line it up. So I got this guy, and I'm going to minus 2 pi. First off, notice that we have this pi term for each of them. And I'm going to factor it to the back. You can put it in the front if you like. Honestly, it doesn't really matter. But I just want to get that pi out of there for a minute. Okay. Can I do this on the calculator? Yes. 59 divided by 6, then minus 2, enter. And I got 47 over 6. And now pi. And the same thing. Is that between 0 and 2 pi? Notice that because we have a division by 6, you could think of it kind of like 12 pi over 6. Isn't that supposed to be a 2? So we have a divide by 6. We're looking to basically stop at some number less than 12. We are not less than 12 yet. And so what I'm going to do in my calculator is basically just say that guy minus 2, enter, and then I'm going to say whatever my answer minus 2, enter, 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 until I get down to something. So minus 2, enter, enter, enter. Oh, I should probably have told you some numbers. Here, this is some audio for you. Okay, so I got 35, 23, 11. Oh, there it is, 11. 11 pi over 6. 11 pi over 6. And that is less than the 12 pi over 6. This right here, this number here in the front is less than the 2, so he's somewhere on my first revolution. So all I'm doing here is minusing 2, minus 2, minus 2, minus 2 until I finally get down to something that works. Here, another thing is that what you could do is minus 2 again. If I minus 2 from that one more time, what I would get is a negative 1/6, negative pi over 6. You don't want a negative, so basically backtrack 1. So keep hitting it until you get a negative. You're like, whoa, 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 that's too far. And then you just back up 1. Okay. Lots of different ways to do it. Oops. There we go. Okay. R is equal to 12 inches. My theta is equal to 145 degrees. And they say find the arc length in inches. Well, S equals R theta. And so then I got 12 times the 145 degrees is equal to... No, 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 no. Must be in radians. It must be in radians. And so I need to convert that first. I think if I do pi over 180, notice what happens. These degree symbols cancel. And so I have 145 divided by 180. And I got 29 pi over 36. I just want to clarify one more time. I am not putting the pi in my calculator. I'm only doing this, and this is what my calculator sees. I am not putting that pi in there. You go ahead and put a pi in there. See what happens with your calculator. You're going to get a decimal. You're always going to get a decimal, and you're going to wonder, man, how did he do it on the video? My calculator's broken. Nope. Your calculator's just fine. Don't include a pi. You know there's a pi there. I'm just getting that thing out the way, just like I had done last time. See how I got the pi out of the way? Just do this part. Don't do the pi. Okay, so I got this. Cool. Now what? This is my radians. That is not the final answer. My final answer is right here. S equals R theta. So let's go back and do what we're doing. My S is equal to R, which was 12, times theta, which is the 29 pi over 36. Calculator. So 12 times 29 divided by 36. And again, I didn't do pi. What am I putting in my calculator? I know you want to look at it. I get that. Maybe I should sometime. I'm putting that in my calculator, and I got 29 over 3, and of course, pi. Now, this is supposed to be in inches. This is exact answer. But like, let's say I go out and I'm like, okay, hey, go measure a piece of wood for me. I need it cut at 29 over 3 pi. And you're like, what? That is totally not anything. I don't know what that means. My ruler doesn't use pies. And so now you put the whole thing in your calculator all at once to see what kind of decimal you're going to get. 29 divided by 3 times the pi. And remember to keep using the pi button. Your calculator has a pi button. If it doesn't, well then find it because it's there. 30.3687, etc. And this is my decimal equivalent in inches. I say, hey, can you go cut a piece of wood at 30 inches and 30.3 inches? And you're like, yeah, I could do that. Okay. 175. So, I got, I think, 2 more problems here. It says the angular speed is going to be in radians per second. I'll write per. Radians per second. Okay, cool. And they want their answer in terms of pi. Okay. They have 10 revolutions per second. So how many radians per second is that? This is a very simple problem, by the way. So they're saying I got a full revolution, and they're wanting to convert that into radians. Well, guess how many degrees is this? We all know degrees, right? That's 360 degrees. So how much is that in radian mode? That's 2 pi radians. So I got 10 of these full circles. Each full circle is 2 pi. So I got 10 times 2 pi is equal to 20 pi. And that's, again, exact answer. This is radians per second. Maybe this is like a wheel on like a car or something. I don't know. Going round and round and round. It went around 10 times, and it did 10 times in 1 second. So how many radians was that? Okay, last one. 5189. It says the minute hand clock. The minute hand on a clock is 12 inches long. Okay. It moves from the 12 o'clock to the 11 o'clock. Okay. How far does the tip move? How far does the tip of the minute hand move? Excellent question. Did they give me something else? Nope, that was it. Okay, let's look at a clock. 12, noon. This is 1, 2. I guess I overdid it. 3. You get the idea now. 1, 2, 3, 4, 5, 6 o'clock, 7, 8 o'clock, 9 o'clock, 10, 11. And I went clockwise. So my minute hand started right here, and it ended up right here. It almost went to full clock. It almost was a full hour, almost. So now let's try to figure this thing out. It said that my radius was 12 inches. Did you see that? Right here. It's 12 inches. So I got a 12-inch long radius that I'm traveling. Okay. And I want to find the arc length. How far did it go? What's my S? S is equal to r theta. Well, I have my r. That's super easy. What I'm missing is my theta. And so I need to know how much theta I had. Think about it for a second. I went 11 out of 12 positions. Right? The only part that I didn't do is this last little bit here. So 11 out of 12 positions, 11 out of 12 of a revolution. And we know that a full revolution is 360 degrees. Yes, but it's also 2 pi radians. So I'm going to multiply it and get 22 pi over 12. Now, I'm sure that'll reduce. I'm not too concerned about that right now because we're going to put it through formula. But this is my radian measure. That's my theta. So S equals r theta. My r was a 12. And my theta is a 22 pi over 12. What happens is that the 12s cancel, and your answer is 22 pi. Now, what is this measurement in? 22 pi. Is it in radians? It got a pi on there. No. This is inches. Remember that this is arc length. Now, again, I'm going to say, well, measure out for me 22 pi inches. And you're going to stare at me like, what? So we want a decimal equivalent. I put that in the calculator. I got 69,115. Again, this is inches. Can you measure out 69 inches? Yes, that's possible. All right, and that's all we got. We're going to do the sine, cosine, and tangent stuff next time. So that's it for now. Thank you very much. Have a great day.